subject I want to speak to you about is really my own impressions, my own experiences in working for a project to which I had no introduction at all. The principal motivation is simply that another generation has moved on and that I seem to be one of the last people who worked on this particular project. Now I hope that you can hear my voice through this arrangement. I want to talk about my recollections of having worked during 2 years of the Second World War at Los Alamos as part of the Manhattan Project. It's in some ways a difficult thing these days to justify. It seemed at that time to be a literal necessity. Well, I'd like to begin with a bit of the prehistory, and for that, let me see if we can go here. Well, yes, okay, we seem to be there now. Yes. Now, do we have, oh yes, we have these two fellows. This is part of the prehistory. Not a great deal was known about the atomic nucleus, and in fact, some of what I was taught in school was thoroughly wrong. I was taught, I think in 1938, that the nucleus has a certain number of protons within it, yes, but a certain number of electrons that balance the charge. And that was already an ancient view and discarded because of the discoveries of two of these people who are more or less familiar to you. The first, on the right, of course, is a picture of Niels Bohr as a relatively young man. A couple of years earlier than this, he felt that the correct picture of the nucleus was like a liquid drop. And this liquid drop can deform and change. It has internal degrees of freedom which work collectively. Our other representative here is James Chadwick, who was the discoverer of the neutron, and that resolved the issue of whether indeed there were electrons within the nucleus. There aren't any that live there permanently. That's how the story started, and in fact it started in that sense in about 1931. Now let's see if we can even change the slides. The discovery of the neutron gave this man, Enrico Fermi, a great inspiration. He was not able to produce beams of neutrons, but he had sources of neutrons, and he subjected the various nuclei available to him to this sort of irradiation of neutrons, and he found some very strange results already as early as 1935 and 1936. He found that the exposure to neutrons produced other radioactivities, and one of the most extraordinary things he found was that if you do these experiments on a wooden table and on a marble top table, you get altogether different results. Now that was remarkable, considering that the nucleus is extremely compact. It deals with energies which are very large compared with anything chemical, it would appear. Well, he understood almost immediately that the wooden table contains light elements, that neutrons striking these light nuclei would lose energy, that these were neutrons that had lost a good deal of energy before they struck the nuclei that he was observing. And somehow or other, slowed neutrons were far more effective in creating nuclear reactions than the faster neutrons. That was a discovery alone sufficient to get him the Nobel Prize. The year was 1938. He came to New York and settled at Columbia University and continued these experiments, but it took him rather a time to set them up again. He had discovered several mysterious things. When he irradiated uranium, he found a considerable assortment of radioactivities generated and was sure that these must be transuranic elements. He was a bit early in that, and someone who didn't quite agree with him was Otto Hahn, a German, and his young assistant, Lise Meitner. The question was, what could be the source of all of these activities generated in uranium? And there was no answer to that. Lise Meitner had to leave Germany, as you know, for Stockholm in 1938. In fact, Hahn gave her a diamond to take with her in case she had to bribe any of the border guards in order to leave the country. She and her nephew, Otto Frisch, whom we'll see later, solved the problem. They understood, in fact, on the basis of Bohr's model, liquid drop model of the nucleus, that what was happening was that the nucleus was put into a state of much higher excitation, and excitation so high, although it was literally unimaginable prior to that, that the nucleus flew apart in two pieces of comparable mass. Now, that raised a number of problems. First, why had it never been observed before? This was an extremely dramatic effect. And the answer was, as well as anyone could tell, that for the sake of laboratory cleanliness, all of the previous investigators had covered their targets, the uranium targets, with a layer of cellophane. Now, cellophane, you know, is a very thin barrier, but these fission fragments could not penetrate the cellophane, and nuclear fission had remained undiscovered for years. Nuclear fission did not exist for very long before the realization occurred that the two half nuclei, if you like, that fly apart, have considerably more neutrons than they ought to for nuclei of that weight in the middle of the atomic table, as it was then known. And one of the first to realize that that means that many neutrons must be emitted. Not only must they be emitted, but emitted with substantial energy, but there would exist then the possibility of a nuclear chain reaction. And the person who realized that perhaps first, but certainly most dramatically, was Leo Szilard. And in early 1939, this is the spring of 1939, he decided that he must warn President Roosevelt of the danger that nuclear chain reactions can be brought about. How should he do that? He visited Albert Einstein, who was on vacation in Long Island, at the far end of the island. He wrote a letter from Einstein to Roosevelt. And the question was, would Einstein be happy enough to sign it? And indeed he was. He was every bit as frightened as Szilard himself of what the consequences might be. It was necessary. How do you get such a letter to the president? The answer is there was a banker, Alexander Sachs, who was personally acquainted with Roosevelt and whom Roosevelt trusted, dating from his governorship of New York State. Sachs delivered the message. Roosevelt was suitably impressed. He consulted Vannevar Bush, who was the chief scientist in a sense, as head of the National Bureau of Standards. He immediately began consulting the principal scientist, anyone who would know about nuclear physics as it stood at that time. And this was the result. Here was one of the early meetings with Ernest Lawrence from Berkeley, Arthur Compton, Vannevar Bush himself, the president of Harvard, James Conant, and the brother of Arthur Compton, who was president of MIT. Well, there was one committee meeting after another. The actual project in America, the literal research on the project, did not begin until a couple of weeks prior to the Japanese attack on Pearl Harbor, which launched the Second World War, as you know, which thrust America into a war not just with Japan, but with Germany and Italy, no less. So there is where my story really begins. It is, excuse me, it is in about 1939. At this point, was there any activity in America? I'm afraid only these committees. About 2 years of time passed in which these committees passed the proposal from one to another, and there was literally no action. In the meantime, the British were very active, and for reasons you must all be aware of. Germany, after considerable practice in bombing in Spain and later in Poland, was waging war on Britain. The Battle of Britain was taking place, and vast quantities of explosives were being dropped on London and several other cities. And in the midst of all this, the British began thinking seriously about the chain reaction. They hadn't an awful lot of equipment, and there was not, in fact, aside from some very good theoretical work carried out to a large degree by Peierls in Birmingham, and a young assistant of his, Klaus Fuchs. The work began there and was already 2 years advanced before anything was done in America. Now, where do I fit into all of this? Not in anything I have told you to this point and to some point later. I was an undergraduate at Harvard beginning in 1941. I was just 16, then entering college, and had gotten off to a fairly fast start, but not a very unusual one. Kids used to skip grades in the elementary classes in those days. The teachers thought it was a good idea not to waste their time. Some got through even much younger than I. I was an undergraduate at Harvard. I had heard a great deal about this man, Kenneth Bainbridge. He was most famous for mass spectroscopy. He had made a long succession of very accurate measurements of the masses of the available nuclei, And those were, in fact, part of the calculations of the energy releases that you could have. All I knew of Bainbridge was that he had disappeared. He was no longer at Harvard. Furthermore, he had built a cyclotron. This is the cyclotron he had built, and there was Bainbridge himself. The cyclotron disappeared. Now, how in the world would a cyclotron disappear? The answer was some military men dressed in uniforms from something called the St. Louis Medical Depot, which did not exist, appeared and took the thing apart piece by piece. And there was one person who was conspicuously not a medical person who was there, and had I known him at that point, I was very well acquainted with him later. This is Robert R. Wilson. He was one of the medical people negotiating for the shipment of the cyclotron. This is Percy Bridgman, who was famous for his work in high pressures and a Nobel Prize winner. But Bridgman himself thought it might be an excellent thing to send the cyclotron to some place that does nuclear physics, but he couldn't imagine its being of much use in a medical institution. Well, it wasn't of much use in any medical institution at that stage. Instead, they packed it up and shipped it to one remarkable address, and that's an address which became very familiar to me. 2 years later, this was, the fall of 1943. I just turned 18. People with any technical background, any technical training were becoming very scarce. There were vast numbers of people being drafted into the Army in order to build up a huge reservoir of manpower, as it were, for the ultimate invasion of Europe. They could not find technical people very easily for new projects. Everyone who had children, who was a bit older, was already doing this sort of work. I was an undergraduate still taking courses. I heard that all of the graduate courses were being given for the last time for the duration of the war, so I jumped into the graduate courses, and by this time, in 1943, I had most of a graduate education. Then, of course, I had to register for the draft myself, and it was very clear that I was going to be in the Army. I would have to tell you that being in the Army was then, perhaps it is no longer, a very random thing. It made essentially no difference what training you had. It made no difference what your skill might be. The Army had no way of determining these things, and the decisions that were made for the allocation of manpower within the Army were, to a large degree, random. Well, I was told I would go into the Army before long. I remember hearing one of the professors explain he was supposed to argue before the draft board, saying that there's this 18-year-old fellow whom we would like to keep because he's already teaching. I had a teaching position while I was an undergraduate. And the members of the draft board, as he explained, he didn't know who I was, this chap, but he explained that the draft board thought he was being silly, that no one 18 could be of any use. And I looked forward to going into the Army. I filled out a questionnaire sent from Washington asking what things you had studied and what you knew. And within a matter of a couple of weeks, a man appeared from Washington, literally seeking me out. He drew me into a dark room and had me fill out all of the elements, 10 or 15 pages about my past. I didn't have much of a past. That was very easy to accomplish. And he would not tell me what he wanted me for. He only would say that there is a place out west, and it doesn't make any difference what you're interested in. They can find a use for you. Well, that seemed to be a better idea than going directly into the Army. I filled out all of his documents, and within a matter of 2 or 3 weeks, I was told to pack up my things and send them to this famous address, Post Office Box 1663, Santa Fe, New Mexico. I later discovered when I got there that many people had had the same experience, and they had packed up all of their belongings in moving vans. There were whole trainloads of things going to Post Office Box 1663, Santa Fe, New Mexico. Now, a post office box in America is approximately 1/4 of a cubic foot in size. So there is something a little strange about this experience. Well, let me show you the sorts of things I found when I got there. The very first person who got out of the train when I got to Lamy, New Mexico, that's as close as you get to Santa Fe, was this gentleman who introduced himself as Mr. Neumann. He had a navy blue overcoat and wore a derby hat, a rather formal fellow it seemed. I later discovered that he was, in fact, John von Neumann. He was a legendary figure at the time, and I had even read part of his book on quantum mechanics. There was a man greeting him who was, to all intents, a cowboy. Now, there are certain well-dressed cowboys in the West, even then, wearing long blue dungarees, a checked shirt, and a 10-gallon hat. I assumed that he was a professional cowboy chauffeur of some sort. Well, I later learned that he was a mathematician named Jack Corkin, who had worked in earlier projects for Neumann. And they began driving north. We had to stop first in Santa Fe. This is one of the first things we saw. However, it's a bit misleading. The original bridge was washed out, and you could not cross the Rio Grande River, which flows north-south there. You had to drive 10 miles further north to the town of Espanola, turn around, and come back down. But the country we began driving through was extraordinary. I had never been in such geography in my life, having grown up all over the eastern U.S., but only in the east. Those are the Sangre de Cristo Mountains, the main range of the Rockies running north-south in New Mexico. This is what was volcanic country, enormously eroded in time, and there is one mesa after another like these, and indeed the laboratory was perched on the mesas. Here was what the entrance to the laboratory looked like, very unassuming at that stage. This was at a point at which the project was only a few months old, and there was a vastly more traffic than you see in this picture. It's a bit more like this. This is what the entrance looked like as I entered for the first time. There was an extraordinary conversation that took place between Mr. Neumann and the cowboy while we were going up. He assumed naturally that if they used technical words that I would have no understanding of what they were doing, that was within the bounds of protection of the story. And so Mr. Neumann asked how things are going up. The cowboy responds, well, not so well. What's the matter? Well, matter is being annihilated. Matter is being annihilated? And listen. The problem is that the world lines, that's relativistic terminology, the world lines are intersecting. Mr. Neumann adds, they can't intersect. They can collide and repel one another. Well, this conversation went on for about a half hour, by which time I thought that whatever suspicions I had of what they might be doing there could only be wrong. A perfectly absurd collection of statements they made. I later turned out that they were working with a very difficult mathematical model having to do with what I'll tell you is the implosion. They didn't have any possibility of integrating the partial differential equations in 3 dimensions, so they worked with a 2-dimensional model. They had not chosen the intervals suitably, so that the mathematics was going crazy as they did it, and indeed they were getting nonsense. And this cowboy, Jack Corkin, was describing the mathematical nonsense in literal terms to von Neumann. I was not informed in any way of what it was they were doing, and that wiped out any hint I had had, which was indeed a hint that they might be working on the chain reaction. All talk about the fission chain reaction had disappeared from the press by the middle of 1939, and nothing was heard of it for that period, and for some period later, I dare say. But I at least thought it would be interesting, it would be fascinating if that's indeed what they were working on. I was completely persuaded that it was not. Let me go on. These pictures, by the way, are not any of them pictures that I took. There are very few pictures in existence of civilian life within the project, and they have mostly been seen many times, so I will go rather quickly through those pictures. But this is a building which was one of the first to be taken down. It was originally, as you may know, the so-called Los Alamos Ranch School for Boys, and it was a place, for example, where parents who were afraid that their sons might have tuberculosis or a touch of it sent them there so that there were open porches for them to sleep on in this building, which is called the Big House. That was one of the first ranch school buildings taken down, however, so virtually no one is familiar with that one. There was a technical area within, of course, everything was fenced. It really didn't need fences because the country was absolutely impassable with these vertical slopes. However, there were fences nonetheless. Those fences became the object of jokes of various sorts as people would find a hole in the fence, go through it, and confound the security people by appearing several times, having left the project in the meantime, but coming back through holes in the fence. The fence accomplished very little, but it was completely surrounded by a high fence with barbed wire. Nobody contended with the barbed wire. There were great holes in the fence, however. Then there was a fenced area within that, and that was the technical area where the literal work was done. This was the entrance to the technical area after it got cleaned up a great deal, maybe 2 years after I went there. The people entering had their belongings examined. I just happened to like this picture because that person is obviously Robert Marshak, who was coming down from the project in Canada at that time to join us. This is what the main street looked like after about 1.5 years. The technical area was that area over on the left, the original technical area. The original theoretical group, which I presently joined, was in this building, but everything was outgrown within a matter of weeks or months. They had to begin on the other side of the street to have still more technical area. That meant putting up these overpasses. The theory group that I worked in was, in fact, in this building. It wasn't, none of them were much in the way of buildings. They were all slapped together in terms of the crudest lumber and pasteboard panels, as you can see. But this was the original housing for families. They would like to have had more families living there, but that if there were literal children, that meant putting up a school as well, which they had to do within the first months, but at some pain. This is a 4-family house, and I would guess there were very few families with more than a husband and wife at this stage. This is a little later, the housing, a winter scene. Excuse me. All right. I just wanted to point out this picture because of the smoke in the background. There was indeed a forest fire within about 4 or 5 miles, and we all had to go out and experience what a forest fire is. And in dry country like that, I can tell you that it is something remarkably impressive. It burns rather quickly, and there is virtually no water available to put it out. One tries to dig, to knock down a few trees, and somehow or other to discourage it. But to put it out is darn near impossible. And there was, a few years ago, about 10 years ago, a vast fire near Los Alamos, which did a great deal of damage to the surrounding forest. This is what the slightly later, I say later housing, 2 or 3 months later, they were building houses completely differently, and this is what they looked like. This early dormitory housed about 15 or 18 women, single women. They were the only single women in the place. And that had some attendant problems. This is what the dormitory room looked like. Not mine, but you couldn't have told it from mine. That's what the inside of one of those rooms looked like. Now, this was something unique to Los Alamos. The Army brought many hundreds of young men there if they had any suspicion that they had any talent that might be of use. But as I was telling you before, that was done really quite randomly, and it led to all kinds of anomalies in the background that people had. But the one thing the Army could be assured of was that these men lived very inexpensively in these long barracks, these dormitories, where they lived perhaps 40 to a room. The problem was that these men, aware that they were being used as inexpensive labor, that in fact they were living the lives of civilians as far as work was concerned, they were nonetheless in the army and being paid essentially nothing. But to add to their problems, and they, I have to say, never stopped complaining about these things, even though they were, in one obvious sense, vastly more fortunate than the young men who were being landed in Europe for the invasion. They had officers, sergeants and an occasional lieutenant, who had no technical background whatever, and felt that there ought to be some trace of military rigor and military behavior. So these young fellows, who were all technicians of one sort or another, either by training or by adoption, were gotten up several mornings a week at 6 in the morning and asked to do some sort of drill by these officers who were men with no technical background whatever. The elegant part of town involved only half a dozen houses, and this memorial stone is of course very recent. There were several houses that housed the faculty of the original the Los Alamos Ranch School. These houses were unique in having bathtubs. Now that doesn't mean that the people elsewhere didn't bathe. They had to use showers, and showers were otherwise universal in Los Alamos. So this became known then, and it still is known as Bathtub Row. Here is the leader of the theory division, Hans Bethe. Bethe was an extraordinary theorist. He never became known for strikingly original ideas, but he knew how to calculate everything, and he knew it better than anyone in the place. He was able to produce calculations to 2 significant figures of anything you might name, however absurd. He was literally a theory division by himself. This is a man I had never heard of in going there, J. Robert Oppenheimer. One could talk for days about the personality of Oppenheimer. Oppenheimer had been something of a young adventurer in Europe in the days in which quantum mechanics already existed, and he then had not an awful lot to add. He did write a famous paper with Max Born. He came to America, having been a 3-year graduate of Harvard, by the way, and with a passionate interest in the Hindu scriptures. He was a brilliant theorist. He had not only a wonderful understanding of theoretical physics as it stood in those years, but a virtually poetic way of expressing these ideas, which inspired everyone. He was, it's hard to imagine, he was a remarkably popular leader of the project, and he got into everything. He paid not an awful lot of attention to the theorists because he was a theorist, and he took all that for granted. But he was present more or less daily at every one of the experimental groups. There he is in his perhaps most characteristic pose, and almost never without a cigarette, and wearing, of course, that inevitable pork pie hat. Here he is at the board, not doing the sort of thing, however, that was being done in those days. And there is his signature. Wherever he went, you could see that pork pie hat. Now here is another individual whom I didn't know at all. I was put in an office the day I came. By the way, Robert Bakker, who was head of the experimental division, asked me whether I had made any guesses of what they were doing there, since I had not yet been told. And I figured, all right, I'll tell him what my own conclusion was, that they were working, in fact, on a nuclear chain reaction. And I told him that I thought probably it was based on uranium-235. And he chuckled and said, well, that's very clever of you, but you know, we did that 1.5 years ago in Chicago. We're working on a chain reaction now, but it's a different one. Huh? What sort of a different one? Well, it was at that point that I learned it was a bomb, and I must say that was very unsettling and remained so for months after that. But the mathematical problems involved in neutron diffusion and in calculating multiplication rates and the like were interesting enough and well enough understood that, in fact, I became rather more reconciled to it. And of course, there was the realization that the German people who had talked about this certainly had reached all of the same conclusions about the possibility of a chain reaction, that it was completely inevitable that there was a project in Germany doing the very same thing. And what was most essential was that we, if it's to be achieved at all, that we achieve it first. I was put in an office with 2 other people, but there was a vacant office next door, and the name Edward Teller was chalked on the panel beneath it, but there was no sign of Edward Teller. Teller had, in fact, not been there for about a month. He had been there in the earliest days of the project, but once he ascertained that he was not going to be leader of the theory division, and that Beta was, he picked up and left. It was some time before Oppenheimer was able to persuade him to come back, and in order to do that, he created another division, a division which would deal with the only problem that at that stage Teller thought had any importance. He took the fission bomb as a foregone conclusion. He assumed there was nothing serious to be done that needed to be done about that, and I must say he was very wrong in that conclusion, but that the only thing that really interested him was the possibility of a thermonuclear reaction, which is a different reaction. It does not require high temperatures at all, fission doesn't, but the thermonuclear reaction is literally a nuclear burning process, and he saw the nuclear bomb, the uranium bomb, as a kind of match to ignite the thermonuclear reaction. And he was given a division of his own, which never had more than 5 or 6 people in it, but he was able, in these years that I was there, to fire off ideas one after another to this group surrounding him, who were able to demonstrate that, as a matter of fact, there were none of them. You could not ignite the thermonuclear reaction in that way. Whoops, now I seem to have lost the connection to the yes, that's it.
Yeah,
Well, I don't know. I've lost the time. This picture, I think one prior to it, if I can get back there. Yes. This is one of the early collaborators with Fermi, Emilio Segre. Emilio Segre was given a rather strange assignment. It was known that not only is uranium-235 an isotope subject to fission, easily inspired fission, but there was among the transuranic elements, which were in fact produced copiously in reactors, another element, plutonium, which has the same property. And so the question was, should we try creating a bomb with plutonium? Well, it was known in the case of uranium-235 that the background of fission taking place spontaneously was rather low. That meant that it was possible, for example, to assemble the pieces of uranium-235 to make them supercritical, to bring them to an explosive configuration. It was possible to do that over a certain interval of time without the likelihood that spontaneously emitted neutrons would begin the chain reaction too early. If the chain reaction begins too early, that's called predetonation, and it produces a very much smaller explosion and perhaps no explosion at all. The interval of time in which the material had to be free of spontaneously emitted neutrons was of the order of milliseconds. And that could be managed by using a gun to shoot one piece of uranium-235 into a hollow structure and create, over the course of some milliseconds, create a highly supercritical assembly. The problem was rather different, it turns out, for plutonium. For plutonium, the spontaneous fission rate is much larger. One did not know initially in the project what it was, because there was no significant amount of plutonium in existence. Well, by the time they had succeeded with the Berkeley cyclotron in creating a literal microgram sample of plutonium, they gave it to Segre to carry out measurements in an isolated place down in a canyon. He did that and discovered that the spontaneous fission rate in plutonium is perhaps 1,000 times greater than in uranium-235. And that meant that the assembly of this explosive affair would have to take place in microseconds, millionths of a second, rather than milliseconds. Well, that was Segre's discovery. There is Segre's group. He's standing over on the left, and the person behind him, who was literally inseparable from him then and for years later, was Owen Chamberlain. The two of them won the Nobel Prize some 10 years or so later as professors in Berkeley, working on the Bevatron machine, and altogether different sort of research. They discovered the antiproton, isolated the antiproton, as it were. Another person, Martin Deutsch, who was the son of a woman who was one of the first students of Sigmund Freud, was there, and he too made many discoveries later as a professor at MIT. Well, I'll just show you a few of the people who were there. This is one of those who became most famous, Richard Feynman. Feynman had a career already as a mathematical prodigy at MIT, where he won math competitions. He became a graduate student, however, at Princeton, and there began thinking about quantum electrodynamics, not entirely correctly at that stage, but Feynman was a fantastic performer. I don't know how else to put it. His father was a salesman of uniforms, industrial uniforms in Long Island. Feynman was a born salesman. And whatever it was that he had to explain to you, he had to do in some strikingly original way. You would get the impression that very little of the mathematics he did had ever been thought before by anyone. That was not true. He had conventional ways of thinking when necessary, but he wasn't going to let on to anyone. Feynman, there he is again, made an extraordinary impression on people at Los Alamos, but to a very large degree as a performer. This is the way we heard our weekly colloquia. This picture happens not to have been taken in a normal colloquium, but it looks just like our normal colloquia, which were held every week on, I think, Tuesday evenings in a huge wooden building built as a gymnasium by the Army. We sat on these canvas chairs, and there you have Norris Bradbury and John Manley and Fermi and Oppenheimer, and I think that's even Feynman behind them. One of the things that the original leaders of the project insisted upon was not following the advice of General Groves, but seeing to it that everybody who was suitably cleared was told the entire story of the project. General Groves would have had it that no one would be aware of what was even going on at the bench or the desk next to his, that is the way you really maintain secrecy. And the scientists who began the project had, by literal threat of resignation, to persuade him that, no, that is not the way you secure progress. You try to solicit the ideas of everyone on the project, and that is the way the place was run. So these weekly colloquia were, in a way, absolutely unique. And one heard the very latest story on every facet of the project, including many of those that did not work at all. Now let me start running through. This is a mathematician. A mathematician whom Teller took into his group, Stan Ulam. And Ulam started out in life as the most abstract mathematician you have ever known. He explained to us that he didn't think that we were doing any correct things on the project, since no one had ever proved the ergodic theorem. Now, if you know, he later took on somewhat more practical interests, and here he is, by the way, with von Neumann and Feynman on a bench in Santa Fe. We got to visit Santa Fe one day a month, coming down by bus and going back up. This is another chap who did not live permanently at Los Alamos, but who would show up every month or so and stay for at least a week. And when he arrived, the PA system, the public address system, which ran throughout the entire project and made infernal noise all the time, announced that Nicholas Bakker would give a lecture. Well, as you might just have guessed, Nicholas Bakker was Niels Bohr, and Bohr was something of an inspiration to the people who could understand him. Not many did. He had the habit, many interesting habits. One of them was to keep smoking his pipe, but usually whatever tobacco was in the pipe had been exhausted long since, and he spent the rest of the day taking a long draft of matches, one after another. So he scarcely smoked anything other than matches. He mumbled when he spoke. He never opened his mouth clearly. You would have to be seated as closely as you might be in this picture to hear any sound from him. And so when he gave a colloquium, care was taken to see to it that he was very well amplified. And you would indeed, for the first minutes, hear some mumblings and rumblings, but he had a way of turning around every time to make a point, and 3 complete turns, and you heard a loud crack, and the connection was broken, and after that, no one could hear a thing. Now, I can tell you there were betting pools on how long Bohr would speak, and in fact, the winner on one occasion was an hour and a half. Here he is. This is a much earlier picture. I wanted something with his son, who was inseparable from him. This is Oa Bohr, and this is Papa, and they're in a heated argument back in Copenhagen. This picture is not Los Alamos at all, but Oa Bohr was so quiet and retiring, never heard a word from him, and it was somewhat amazing at the conclusion of the war that Columbia actually had heard enough from him to make him a professor. And that was then the occasion for his being offered a position back in Copenhagen. This, of course, is General Groves. He was the overall commander, and remarkable for his career in procurement for the Army and for carrying out certain engineering projects. He was the man who built the Pentagon building in Washington. But his acquaintance with science ended at just about that point. So it is amazing that he eventually developed enough trust. It was not quite enough trust because he did imagine that the scientists who were working for him were madmen, each and every one. But he somehow developed a trust of Oppenheimer, and Oppenheimer was very, by the way, this is the way the portrait of the general looked after the war. The two acted together as a kind of joint personality, and a remarkable one. They were about the 2 least probable people you can imagine collaborating with one another. In terms of basic beliefs, they had really remarkably little in common. And even more remarkable, perhaps, was the fact that Groves did develop a certain trust of Oppenheimer, because Oppenheimer had indeed as colorful a past as was eventually revealed in the later years when Oppenheimer's enemies did their best to do away with him. So it was a remarkable accomplishment of Groves to trust Oppenheimer to that degree. And Oppenheimer must have developed an altogether different means of communication in order to persuade Groves to go along with many of the things he had to go along with. This is Fermi, I presume at Columbia, wearing a vest, obviously not at Los Alamos. This is Wigner, who never was at Los Alamos, but who directed very important work on the design of reactors in Chicago. This is the way one spent time in the winter. The way we had wooden skis, and it put up a ski tow nearby. There was a great deal of traipsing up and down the hills. There is Fermi, Beta, Hans, a Swiss chap, his name will come back. Maybe I even have it here. Yes, Hans Staub, I might have known. And Vicky Weisskopf, Bruno Rossi, several of the wives. This was quite an agreeable experience in these very dry and crisp winters. This is a picture I love mostly because it shows all of these characters who went their separate ways. This is Rudy Piles. This is a fellow named Gentile. This is John Carlo Wick. Now that sounds like an English name. He was in Italy during the war years, and he was writing papers on essentially the same subject that I was writing papers on. His were being published in the Zeitschrift für Physik on radiative transfer, which is mathematically almost the same problem as neutron diffusion. This is Felix Bloch, and that is Vicky Weisskopf in the background. This is a fellow named Sauter, but this is a fellow named Heisenberg. And I think I've named all of them except one who was in Canada. He led the project in Canada in Chalk River. And that was, George Plotchak. These people all knew one another rather closely. They went off and led their respective projects. Felix Bloch left Los Alamos. He decided he did not want to do that sort of work and went back to Stanford. The others did precisely this sort of work during the war. This is not very important. The early design for the Chicago pile, reactor, was to be cubic in shape, and they thought that they could suffuse hydrogen through it, that would help the reaction. And having done that, they would need cubic balloons, rubber balloons, to contain the hydrogen. That was an assignment for General Groves, to get Akron, the rubber industry, to produce cubic balloons. This was the Oakridge electromagnetic separation plant. It became a huge project, you see, as the war went on. This is the Hanford project, which produced eventually the plutonium, and had the awful experience that when they finally began running the reactors for the first time, over the course of one day, the density of neutrons in them just decreased and went slowly to zero. And that it seemed to indicate that the project was a total failure. The difficulty was that there was a very rarely produced fission fragment, which happened to be unbelievably absorptive of neutrons. It had a cross-section thousands of times larger than any cross-section for absorption that had ever been measured. Had that fact ruled the day, there never would have been any success at all from the Hanford reactor. But like good engineers, they over-designed the reactors so that there was more radioactivity present, and they they were able to get a sufficient flux to remain within the reactors. There is the current appearance of the one remaining reactor. Here is something, an early experiment. I'll go through these things quickly. That was begun. I have included some pictures that you probably have not seen before. This is something that was being built. Here is a later stage of its being built, before the Trinity test. That was about 100 tons of high explosive, which was to be blown up in order to measure what the blast effect was at various distances and to see how the radioactive materials are circulated atmospherically. So that was just a kind of normalization test. Now, this is another experiment which was to be performed. In the first year, they designed something to contain a small explosion that would be necessary in order to initiate the reaction, on the assumption that the eventual full explosion would not take place. That was a container, one of the largest pieces of steel ever fabricated, and it was given the name Jumbo. It was to contain a failed bomb, as it were. There it is being delivered in Alamogordo, New Mexico. After the war, they didn't use it during the war. They felt they didn't need it. After the war, someone who was just curious about what the strength of this thing really was put about 100 pounds of TNT. It's a very small quantity that compared with what the bomb would use. And detonated the thing, and look what it did to Jumbo. Not everything that went on in this project was successful. There you saw the tower. Here is the bomb at Trinity prior to its detonation. And there, examining the thing is a familiar profile, just a shadow on a tarpaulin. There he is. Oppenheimer was every place where the essential work was being done, and there he is prior to the detonation of the bomb. There we are with the bomb ready to go off. Now, the essential thing in this spherical bomb, the implosion bomb, an inward explosion, is that all of the points at which the explosion takes place on the sphere must blow off identically at the very same moment of time, or else what happens within this sphere is approximately chaos. I'd have to say there was a great deal of chaos anyway, because wherever two blast waves intersected, jets were formed. So it was not a simple spherical thing, decreasing in radius uniformly. And in fact, part of the solution was to begin not with a spherical shell, but a solid sphere of a lower density. Well, there it is after a couple of milliseconds, the explosion at Alamogordo. There it is some seconds later. There's an interesting thing here, which is called the cloud chamber effect. That's what I saw from a distance of 100 miles going up a mountain near Albuquerque and watching with others. The compression wave expands spherically, but if it goes through a layer with humidity in the atmosphere, it compresses it and then suddenly expands it, and you get these cloud chamber effects. This is what it looked like from above. There is the green glass which melted the surface of the desert. There is where the other explosion to normalize was set off, the wooden platform you saw with the 100 tons. This is looking at what was left. There, of course, is inevitably Oppenheimer and Groves together Weisskopf here. This is the bomb that was being sent to Japan and Tinian. The implosion bomb, which was the first one used, was already sent by boat before the Trinity test. The confidence was that great that the thing would work. These are some of the British who had been present. There is Lord William Penny of the Kronig-Penny model, you may know. He was a quantum mechanician. Earlier, he became Britain's great expert on the theory and practice of bombing. This is Otto Frisch, the nephew of Lisa Meitner. This is Rudy Piles, and I think this is Cockcroft, part of the group that was with us during the war. The news, of course, was sent, the shot had to take place during the Potsdam Conference, and indeed, it's more than likely that Stalin was informed of it, perhaps as well as Truman. Truman knew nothing of the bomb project until he became president, which was only a couple of months earlier. This is an award at Los Alamos. Oppenheimer, General Groves, the Army-Navy E. This is a sort of routine award that is given to any organization in America that produced shoes or shirts or whatever. And it was awarded to us, no less. And here was a man, the president of the University of California, who had never been in the place. The University of California was the contractor for the project. There is the president of the University of California accepting the award. Well, Oppenheimer, of course, became a great man immediately. Whoops, yeah, you have him here in 1947. There is General Marshall. There is Conant. There's Omar Bradley. Several other dignitaries. But Oppenheimer, they discovered, a Harvard graduate, is there in 1947 to get an honorary degree. This is theoretical physics. I won't dwell on this. These are some famous theorists in 1947 at a meeting in Long Island. It's when theory really started up again. There is Fineman, of course, in the middle, and Willis Lamb and Oppenheimer. Oppenheimer went to the Institute for Advanced Study in Princeton as director. He brought a couple of students with him. He was generously recommended by a man named Strauss, Louis Strauss, who was on the board of directors of the Institute. There is Oppenheimer on a later issue of Time magazine, a year or two later. He's quoted as saying, "What we do not understand, we explain to each other." He was very good at making such statements. Here he is allegedly consulting with Einstein. The truth is the two had almost nothing to do with one another, but it was necessary for the purposes of Life magazine to have them together. Here he is making more of his fearsome statements. Whoops, here begins a new phase. 1949, the Russians developed the bomb. Teller begins to sound off that the Americans have been stupid in not developing the hydrogen bomb. No one had any real suggestion for what the hydrogen bomb was ever supposed to accomplish, aside from being a still greater deterrent, as it were, to the Russians. Admiral Strauss became Atomic Energy Commissioner, if you can imagine that. He had no technical background at all. And there is Teller, who became America's great prophet, again given an award by Kennedy, a presidential award. He was warning the country. Here he is in his turn as the country's built-in prophet. Eventually, the president decided that Oppenheimer had been treated rather badly. This was after an extraordinary loyalty proceeding in which they decided, this committee with Strauss as chairman, that Oppenheimer had been disloyal. There was not a trace of evidence of it, but they certainly worked hard to secure the information they had. They had his telephone tapped and all his lawyers' telephones tapped for the entire period. So there is President Johnson congratulating him, and who comes up after this but Teller to congratulate Oppenheimer, having in effect denounced him for years. He congratulates Oppenheimer, and Oppenheimer at that point said, "I think I don't know what you mean." Whoops, well, this prior picture there is Teller. At this point, Teller was advocating a scheme for putting bombs in orbit around the Earth, it was a literally nonsensical proposal, but Teller went on to rule the day for another year or two, and there he is again in his element. I just included these things because I had never imagined that I was going to know closely two people whose pictures were on postage stamps. Here is, of course, Bohr smoking his inevitable pipe, and no matches in sight at the moment. But he ends up on the 500 krona note with the same pipe. And here, outside Fuller Lodge in Los Alamos, you have immortalized Oppenheimer and General Groves, with Oppenheimer apparently about to heave a snowball at the general. Well, with that, let me stop. I have other pictures of several famous people, but I think I've let it get a little too late and have lost track of the time entirely thanks to this problem here. So let me conclude, and maybe at some other point I'll show you a few pictures of some people you do know. Thank you.